Then I
wish to extend greetings and friendly wishes to all who may encounter this Voyager and receive this message.
Enviar a todos los seres del universo un afectuoso mensaje de paz y felicidad. Que el futuro nos depare la
Ook
oportunidad.
België stuurt zijn groeten de ruimte in aan boord van de Voyager. En hoopt dat deze boodschap als ook...
And good luck, Pandisi Wanadepan. Salon, a member of the Committee on Outer Space, and we believe, say, this committee good for we...
My dear friends in outer space, as you probably know, my country is situated on the west coast of the continent of Africa, a landmass more or less in the shape of a question mark in the center of...
در کمیته استفاده صلحجویانه از فضای ماورای جو افتخار دارم شادباش‌های مردم ایران.
Ni strebas vivi en pace con la popolo della tutta mondo della
Vi såg en nebulosa i en tub. En gyllene dimflock tyckte vi oss se. I större tuber kunde den sig te som 1000 solars ofattbara rum. Vår tankes svindel föreställde sig att den sig lyfte högt från jorden kring. Från tid och rum, vår livsnaivitet till andra dimensioners majestät. Där härskar ingen lag av livets sort. Där härskar lagarna för världars värld. Där bölja solarna till mognad bort och klinga in i alla solars härd. En rikedom av solar finnes där. Var sol pulserar där med allt ett slag. I större solars oerhörda sken. Och allt är klarhet där och dagars dag.
As the Secretary General of the United Nations, an organization of 147 member states who represent almost all of the human inhabitants of the planet Earth, I send greetings on behalf of the people of our planet. We step out of our solar system into the universe seeking only peace and friendship, to teach if we are called upon, to be taught if we are fortunate. We know full well that our planet and all its inhabitants are but a small part of this immense universe that surrounds us and it is with humility and hope that we take this step.
Silema gemen.
Oitenis poteste chairete. Eirenikos pros philos eleluthamen philoi.
Paz e felicidade a todos.
各位好嘛，祝各位平安健康快樂。
Adanish lushulmu.
Здравствуйте, приветствую вас.
สวัสดีค่ะสหายนายธรณีพลพวกเราในธรณีนี้ขอส่งมิตรจิตมาถึงท่านทุกคน
تحياتنا للأصدقاء في النجوم يا ليت يجمعنا الزمان.
Salutări la toată lumea.
Bonjour tout le monde.
Mae lakmia.
Shalom.
Hola y saludos a todos. Selamat malam hadirin sekalian. Selamat berpisah dan sampai bertemu lagi di lain waktu.
Kay pachamatna, pitapas, maitapas, rimapayast, runasimit.
Audigiano.
Ashuli.
Namaskar. Bishe Shanti Hok.
Salvete quicumque estis. Bonam erga vos voluntatem habemus, et pacem per astra ferimus.
Shalom.
Hartelijke groeten aan iedereen.
Herzliche Grüße an alle.
अस्सलाम वालेकुम हम ज़मीन के रहने वालों की तरफ से आपको खुश आमदीद कहते हैं.
Chân thành gửi tới các bạn lời chào thân hữu.
Sayın Türkçe bilen arkadaşlarımız, sabah şeriflerinize hayırlı olsun.
Konnichiwa, o genki desu ka?
धरती के वासियों की ओर से नमस्कार.
Yechidai chui an aur aganoisoid.
Tanti auguri e saluti.
Aibuan.
Sia ni bingalela makawe, snifisela ingonzo ende. Pria dumelisa marena.
Sanada kaho.
Polor anons, borgă cât nevin, diezerki mikamazuchuneren antin, fortuner.
안녕하세요. Witajcie, istoty z zaświatów.
पृथ्वीवासीहरूबाट शान्तिमय भविष्यको शुभकामना.
各位都好吧，我们都很想念你们，有空请到这儿来玩。
Hälsningar från en dataprogrammerare i den lilla universitetsstaden Ithaca på planeten jorden.
પૃથ્વી ઉપર વસનાર એક માનવ તરફથી બ્રહ્માંડના અન્ય અવકાશમાં વસનારાઓને હાર્દિક અભિનંદન. આ સંદેશો મળે વળતો સંદેશો મોકલાવશો.
Пересилаємо привіт із нашого світу, бажаємо щастя, здоров'я і многоя літа.
درود بر ساکنین ماورای آسمان ها. بنی آدم اعضای یک پیکرند که در آفرینش ز یک گوهرند. چو عضوی به درد آورد روزگار دگر عضوها را نماند قرار.
Želimo vam sve najlepše sa naše planete.
ସୂର୍ଯ୍ୟ ତାରକାର ତୃତୀୟ ଗ୍ରହ ପୃଥିବୀରୁ ବିଶ୍ୱ ବ୍ରହ୍ମାଣ୍ଡର ଅଧିବାସୀମାନଙ୍କୁ ଅଭିନନ୍ଦନ.
Muslayo mutiabantu bensieno mukama bawemirembe bulijo.
नमस्कार. या पृथ्वीतील लोक तुम्हाला त्यांचे शुभ विचार पाठवतात आणि त्यांची इच्छा आहे की तुम्ही या जन्मी धन्य हो.
太空朋友，您好，您食飽未？有影就嚟阮家坐哦. Üdvözletet küldünk magyar nyelven minden békét szerető lénynek a világegyetemen.
Namaste. తెలుగు మాట్లాడే జనముల నుంచి మా శుభాకాంక్షలు.
Milí přátelé, přejeme vám vše nejlepší.
नमस्ते. कन्नडिगर परवागी शुभाशयಗಳು.
सब लोगों ने मारो राम राम पहुँचे. हमें अठे राजी खुशी हाँ, तुम्हें उठे राजी खुशी रह जाओ.
Hello from the children of planet Earth.
يا معشر الجن والإنس إن استطعتم أن تنفذوا من أقطار السماوات والأرض فانفذوا لا تنفذون إلا بسلطان.
Saya ingin menyampaikan sekedar pesan singkat melalui satelit Voyager ini.
Au-dessus des étangs, au-dessus des vallées, des montagnes, des bois, des nuages, des mers, par-delà le soleil, par-delà les éthers, par-delà les confins des sphères étoilées, mon esprit, tu te meus avec agilité, et comme un bon nageur qui se pâme dans l'onde, tu sillonnes gaiement l'immensité profonde, avec une indicible...
मैं अपने मुल्क की जानिब से हमारे दोस्त जो खला में बसते हैं उनके लिए दोस्ती और खैर सगाली का पैगाम पेश करता हूँ. हमारी दिली ख्वाहिश है कि सारी दुनिया में अमन रहे और ये अमन जिंदगी के हर
Liebe Freunde im All, als Vorsitzender des Weltraumausschusses der Vereinten Nationen und Vertreter Österreichs freue ich mich, Ihnen auf diesem Wege unsere Grüße.
I should like to extend the greetings of the government and the people of Canada to the extraterrestrial inhabitants of outer space.
Then avec
I wish to extend greetings and friendly wishes to all who may encounter this Voyager and receive this message.
Enviar a todos los seres del universo un afectuoso mensaje de paz y felicidad. Que el futuro nos depare la oportunidad.
Ook België stuurt zijn groeten de ruimte in aan boord van de Voyager. En hoopt dat deze boodschap als ook...
And good luck, Pandit Simona-Deepan. Salon, a member of the Committee on Outer Space, and we believe, say, this committee good for we...
My dear friends in outer space, as you probably know, my country is situated on the west coast of the continent of Africa, a landmass more or less in the shape of a question mark in the center of...
در کمیته استفاده صلحجویانه از فضای ماورای جو افتخار دارم شادباش‌های مردم ایران.
Ni strebas vivi en pace con la popolo della tutta mondo della
Vi såg en nebulosa i en tub. En gyllene dimflock tyckte vi oss se. I större tuber kunde den sig te som 1000 solars ofattbara rum. Vår tankes svindel föreställde sig att den sig lyfte högt från jorden kring. Från tid och rum, vår livsnaivitet till andra dimensioners majestät. Där härskar ingen lag av livets sort. Där härskar lagarna för världars värld. Där bölja solarna till mognad bort och klinga in i alla solars härd. En rikedom av solar finnes där. Var sol pulserar där med allt ett slag. I större solars oerhörda sken. Och allt är klarhet där och dagars dag.
Katai Kaya Kweko Gosi, Te Gamburusi Ketak Zakwe Osigat.
jana trekula wapting nisrani upaha sonsoha tanka malakate jana trekula wachkan nisrani upaha sonsoha pacha chalata kanyaka chiwapting nisrani upaha sonsoha Raja Raja la kapte chakam eka chiwachkam nisra
As the Secretary General of the United Nations, an organization of 147 member states who represent almost all of the human inhabitants of the planet Earth, I send greetings on behalf of the people of our planet. We step out of our solar system into the universe seeking only peace and friendship, to teach if we are called upon, to be taught if we are fortunate. We know full well that our planet and all its inhabitants are but a small part of this immense universe that surrounds us, and it is with humility and hope that we take this step.
Oh
con una cinta morada, yo tenía mi cascabel.
Y como era de europeo, y como era de europeo, se lo di a mi prenda amada, para que jugara con él.
Ay, como rezó paisana.
Ay, como resulta y suena, resulta y va resultando, mi cascabel en la arena.
Anoche por la ventana platicando con Leonor, anoche por la ventana.
Me pidió que le cantara el cascabel por menor, y que no me dilatara, me lo pedía por favor.
Ay, como rezó paisana.
Ay, como resulta y suena, resulta y va resultando, mi cascabel en la arena.
गोरी खेलत काना रे जात कहाँ हो अकेले जात कहाँ हो अकेले जात कहाँ
يا معشر الجن والإنس إن استطعتم أن تنفذوا من أقطار السماوات والأرض فانفذوا لا تنفذون إلا بسلطان. صدق الله.
Saya ingin menyampaikan sekedar pesan singkat melalui satelit Voyager ini.
Au-dessus des étangs, au-dessus des vallées, des montagnes, des bois, des nuages, des mers, par-delà le soleil, par-delà les éthers, par-delà les confins des sphères étoilées, mon esprit, tu te meus avec agilité, et comme un bon nageur qui se pâme dans l'onde, tu sillonnes gaiement l'immensité profonde avec une indicible.
मैं अपने मुल्क की जानब से हमारे दोस्त जो खला में बसते हैं उनके लिए दोस्ती और खैर सगाली का पैगाम पेश करता हूँ। हमारी दिली ख्वाहिश है कि सारी दुनिया में अमन रहे और ये अमन जिंदगी के हर
Liebe
शोबे
Freunde
में हो।
im All, als Vorsitzender des Weltraumausschusses der Vereinten Nationen und Vertreter Österreichs freue ich mich, Ihnen auf diesem Wege unsere Grüße.
I should like to extend the greetings of the government and the people of Canada to the extraterrestrial inhabitants of outer space.
Silema gemen.
Oitenis poteste chairete. Eirenikos pros philos eleluthamen philoi.
Paz e felicidade a todos.
各位好嘛，祝各位平安健康快樂。
Adanish lushulmu.
Здравствуйте, приветствую вас.
สวัสดีค่ะสหายนายธรณีพลพวกเราในธรณีนี้ขอส่งมิตรจิตมาถึงท่านทุกคน
تحياتنا للأصدقاء في النجوم يا ليت يجمعنا الزمان.
Salutări la toată lumea.
Bonjour tout le monde.
Mae lakmia.
Shalom.
Hola y saludos a todos. Selamat malam hadirin sekalian. Selamat berpisah dan sampai bertemu lagi di lain waktu.
Kay pachamatna, pitapas, maitapas, rimapayast, runasimip.
Audigiano.
Ashuli.
Namaskar. Bishe shanti hok.
Salvete quicumque estis. Bonam erga vos voluntatem habemus, et pacem per astra ferimus.
Shalom.
Hartelijke groeten aan iedereen.
Herzliche Grüße an alle.
अस्सलाम वालेकुम हम ज़मीन के रहने वालों की तरफ से आपको खुश आमदीद कहते हैं
Chân thành gửi tới các bạn lời chào thân hữu.
Sayın Türkçe bilen arkadaşlarımız, sabah şeriflerinize hayırlı olsun.
Konnichiwa. O genki desu ka?
धरती के वासियों की ओर से नमस्कार.
Yechidai chui an aur aganoisoith.
Tanti auguri e saluti.
Aibuan.
Siyanibingelela maqhawe, sinifisela inkonzo ende. Ria dumelisa marena.
Sonadakaho.
Բոլոր անոնց, որ գտնվին դիեզերքի միքամազություններեն անտին, ողջույններ.
안녕하세요. Witajcie, istoty z zaświatów.
पृथ्वीवासीहरूबाट शान्तिमय भविष्यको शुभकामना
各位都好吧，我们都很想念你们，有空请到这儿来玩。 Hälsningar från en dataprogrammerare i den lilla universitetsstaden Ithaka på planeten jorden.
પૃથ્વી ઉપર વસનાર એક માનવ તરફથી બ્રહ્માંડના अन्य અવકાશમાં વસનારાઓને હાર્દિક અભિનંદન. આ સંદેશો મળે વળતો સંદેશો મોકલાવશો.
Пересилаємо привіт із нашого світу, бажаємо щастя, здоров'я і многоя літа.
درود بر ساکنین ماورای آسمان ها. بنی آدم اعضای یک پیکرند که در آفرینش ز یک گوهرند. چو عضوی به درد آورد روزگار، دگر عضوها را نماند قرار.
Želimo vam sve najlepše sa naše planete.
ସୂର୍ଯ୍ୟ ତାରକାର ତୃତୀୟ ଗ୍ରହ ପୃଥିବୀରୁ ବିଶ୍ୱ ବ୍ରହ୍ମାଣ୍ଡର ଅଧିବାସୀମାନଙ୍କୁ ଅଭିନନ୍ଦନ.
Muslayo mucha abantu bensi yeno mukama bawe mirembe bulijjo.
नमस्कार. या पृथ्वीतील लोक तुम्हाला त्यांचे शुभ विचार पाठवतात आणि त्यांची इच्छा आहे की तुम्ही या जन्मी धन्य हो.
太空朋友，您好，您家爸爸，有人来阮家坐哦。
Üdvözletet küldünk magyar nyelven minden békét szerető lénynek a világegyetemen.
Namaste. తెలుగు మాట్లాడే జనముల నుంచి మా శుభాకాంక్షలు.
Milí přátelé, přejeme vám vše nejlepší.
नमस्ते. कन्नडिगर परवागी शुभाशयಗಳು.
सब लोगों ने मारो राम राम पहुँचे, हमें अठे राजी खुशी हाँ, तुम्हें उठे राजी खुशी रह जाओ.
Hello from the children of planet Earth.
This is Voyager Launch Control. Weather on Channel 20. 69 minutes, 38 seconds and counting. The loading of Centaur's 9,400 gallons of extremely cold liquid hydrogen fuel is underway at this time. The countdown for the launch of Voyager at 8:56 a.m. this morning continues to go well. The loading of the gaseous helium, which is used to pressurize Centaur's propellant tanks, is also underway and should be completed at the T-minus 60-minute mark. One final built-in or planned hold remains in the countdown. This hold is of 10 minutes duration and comes at the T-minus 10-minute mark. Weather conditions are acceptable for this morning's launch attempt. The count now stands at T-minus 69 minutes and counting. This is Voyager Launch Control. This is Voyager Launch Control. The count now stands at T-minus 59 minutes, 54 seconds and counting. The loading of the gaseous helium used to pressurize Centaur's propellants has been completed, and preparations remain on schedule for the launch of Titan Centaur 6 with Voyager 1 at 8:56 a.m. Eastern Daylight Time. This is Voyager Launch Control. This is Voyager Launch Control. The count now stands at T-minus 49 minutes, 28 seconds and counting. We remain on schedule for a liftoff of Titan Centaur 6 with Voyager 1 at 8:56 a.m. Eastern Daylight Time. To summarize launch preparations to this point, the countdown for launch began at 9:21 p.m. Sunday evening. Initial preparations included powering up the Centaur for a series of propulsion, hydraulic, and pneumatic preparations. Removal of the 240-foot tall mobile service tower, which provided 360-degree access to the space vehicle during flight preparations, was moved back to its pad, to its park site at Complex 41 this morning, with the move completed shortly after 5 a.m. The two liquid stages of the Titan rocket were loaded with fuel and oxidizer last Thursday and Friday. These two stages use Aerozine 50 as a fuel and nitrogen tetroxide as an oxidizer. They are hypergolic, meaning they ignite on contact, and no ignition system is needed. Unlike the cryogenic or super cold fluids aboard the Centaur stage, these liquids are storable. Loading of liquid oxygen and liquid hydrogen for Centaur began shortly after the count emerged from a 60-minute built-in hold at 6:51 a.m. this morning. Some 2,800 gallons of liquid oxygen and 9,400 gallons of liquid hydrogen will be aboard Centaur at liftoff. Topping off of these propellants will continue until the final moments of the countdown to ensure that a full supply is aboard at liftoff. One built-in hold remains in the count. This is of 10 minutes duration and comes to the T-minus 10-minute mark. Weather conditions are acceptable for launch. Surface winds are 5 knots out of the southwest. The maximum winds at altitude are 45 knots out of the northeast at 92,000 feet. Cloud coverage is 2/10 from 1,600 to 2,500 feet, 2/10 from 12,000 to 15,000 feet, and 6/10 from 26,000 to 33,000 feet. The temperature at launch time should be about 80 degrees. All continues to go well in the countdown at this time. The count now stands at T-minus 47 minutes, 21 seconds and counting. This is Voyager Launch Control. This is Voyager Launch Control. The count now stands at T-minus 38 minutes, 25 seconds and counting. All continues to go well at this time. We're heading for a liftoff at 8:56 a.m. Eastern Daylight Time. A spin-up boost test of the Centaur boost pumps has just been performed. These two pumps are driven by hydrogen peroxide and deliver the initial charges of liquid hydrogen and liquid oxygen to the Centaur engines at the proper pressure for ignition. After ignition, the engine burn is self-sustaining through turbo pumps. The count now stands at T-minus 37 minutes, 54 seconds and counting. This is Voyager Launch Control. This is Voyager Launch Control at T-minus 28 minutes, 57 seconds and counting. The chill down of the Centaur's propulsion system with extremely cold liquid helium has been completed. Liquid helium is supplied from the pad, and its extreme coldness, about 450 degrees below 0 Fahrenheit, prepares the Centaur's pumps to handle the super cold or cryogenic fluids which the Centaur stage uses as propellants. The chill down reduces the shock of contraction and other stresses when liquid hydrogen at a temperature of 423 degrees below zero begins to flow through the system. Pre-chilling the system also ensures that the fuel enters the combustion chambers as a liquid rather than a gas. Chill down will be continued from pad sources until 7 seconds prior to liftoff. During flight, the chill down process will be continued by bleeding small amounts of liquid hydrogen through the system. The count now stands at T-minus 28 minutes, 5 seconds and counting. This is Voyager Launch Control. This is Voyager Launch Control at T-minus 25 minutes, 11 seconds and counting. The countdown continues to go well at this time. Voyager 1, like its sister spacecraft, Voyager 2, carries a phonograph record called Sounds of Earth on the chance that intelligent beings might someday capture the spacecraft as they continue on their voyages through interstellar space. The 12-inch copper disc contained greetings from Earth people in 60 languages, samples of music from different cultures and eras, and natural sounds of surf, wind, and thunder, birds, whales, and other animals. These records contain electronic information that an advanced technological civilization could convert into diagrams, pictures, and printed words, including a message from President Carter. They also carry this message from Kurt Waldheim, Secretary General of the United Nations.
As the Secretary General of the United Nations, an organization of member states who represent almost all of the human inhabitants of the planet Earth, I send greetings on behalf of the people of our planet. We step out of our solar system into the universe seeking only peace and friendship, to teach if we are called upon, to be taught if we are fortunate.
The records are attached to the sides of the main body of the spacecraft in prominent locations. It contains, in scientific language, information on how the records are to be played using the cartridges and needles provided. The theory is that if other beings are intelligent enough to capture the spacecraft, they are sufficiently intelligent to bring the record sounds and pictures to life. The count now stands at T-minus 23 minutes and 30 seconds and counting. This is Voyager Launch Control. This is Voyager Launch Control at T-minus 19 minutes, 14 seconds and counting. The launch team has just completed a range safety command test. The countdown continues to go well, and we're on schedule for a liftoff of Voyager 1 at 8:56 a.m. Eastern Daylight Time. In a scientific aside, some of us present for launch today may not be present when the Voyagers make their closest approaches to star systems outside the solar system. Both Voyagers will escape the solar system in the 1990s, traveling at a velocity of about 38,700 miles per hour. After leaving Saturn in 1980, Voyager 1 will be aiming at the constellation Ophiuchus and will make its first approach to a star in the constellation Ursa Minor 40,340 years after launch. Voyager 2 will pass within 1.1 light years, or 6.6 trillion miles, of that same star some 44,250 years after launch. About 525,000 years after launch, Voyager 1 will approach within 1.5 light years of a star in the constellation Taurus. Some 147,000 years after launch, Voyager 2 will pass within 2 light years of a star in the constellation Sagittarius. A light year is about 6 trillion miles. The count now stands at T-minus 17 minutes, 55 seconds and counting. This is Voyager Launch Control. This is Voyager Launch Control at T-minus 14 minutes, 36 seconds and counting. We remain headed for that on-time liftoff of Titan Centaur 6 with Voyager 1 at 8:56 a.m. Eastern Daylight Time. The launch of Voyager 1 was originally scheduled for September 1st, but apparent problems aboard the Voyager 2 spacecraft launched August 20th resulted in a 4-day delay for analysis. Charles Colhase, Mission Analysis and Engineering Manager for Voyager for the Jet Propulsion Laboratory, has provided this analysis of Voyager 2's current health and modifications made to the Voyager 1 spacecraft being launched today.
This is a status report on the Voyager 2 and Voyager 1 spacecraft. Voyager 2 is healthy and in a stable cruise mode, locked onto the Sun in Canopus. A set of star pictures indicated that its science boom is within half a degree of full deployment and offers no problem in the planned use of the optical instruments on the scan platform. The mid-course maneuver of Voyager 2 originally scheduled for launch plus 6 days, has been postponed until launch plus 54 days, but will be only 12 meters per second in size. After holding detailed reviews to understand the in-flight anomalies experienced by Voyager 2, the following corrective actions have been taken on the Voyager 1 spacecraft, scheduled for launch on Labor Day. 2 leaf springs have been added to the Science Boom actuator to double the deployment torque. 2 torsion springs have been added to the Science Boom strut, and an additional 2 torsion springs have also been added to the RTG boom strut. Fixes have been made to the onboard computer software to desensitize some of the fault protection thresholds and to fix anomalies in the attitude control computer. A major objective of Voyager 1 is to fly close to the Galilean satellite Io, passing through a region known as the flux tube, where Io blocks the flow of charged particles along the magnetic field lines of Jupiter. Good Io-intensive Voyager 1 missions exist out through launches as late as September 13, with the last chance to hit the Io flux tube on September 15.
The count now stands at T-minus 12 minutes, 9 seconds and counting. All continues to go well at this time. This is Voyager Launch Control. This is Voyager Launch Control. The count now stands at T-minus 10 minutes, 30 seconds and counting. We're just about to enter that final 10-minute hold. We will punch up the command circuits so you can hear the action underway in the blockhouse. This is Voyager Launch Control. We are now on that final 10-minute built-in hold. This is an evaluation period during which a number of last-minute checks will be conducted by the launch team in the vertical integration building to make certain that the rocket and spacecraft are ready for launch. The 1,800-pound Voyager spacecraft being launched today is the second of 2 being hurled on ambitious survey missions of the outer planets. During the Voyager's decade-long missions, they could explore as many as 15 major heavenly bodies. These include gigantic Jupiter, ring Saturn, several moons of both planets, and possibly Uranus. The twin spacecraft will be making measurements and taking close-up pictures, returning information to Earth that could shed new light on the origin and early history of the solar system and our own planet Earth. The Voyagers will swing past Jupiter at 4-month intervals in 1979 and fly past Saturn and its curious rings in 1980 and 1981. Voyager 2, launched August 20th, has a possibility of making a flyby of Uranus in 1986. Voyager 2 set a new speed record for a spacecraft when it was hurled toward the outer planets with a velocity of 32,325 miles per hour. Voyager 1 will set still another speed record for interplanetary hot rods. Its velocity at interplanetary injection will be 32,481 miles per hour. That's about 9 miles per second. The Jupiter-Earth distance at liftoff today is 497 million miles. Voyager 2, now underway for more than 2 weeks, will be some 8.7 million miles from Earth as of 3 p.m. today, traveling with a velocity of just under 22,000 miles per hour. Since launch, it has traveled a distance of 35.5 million miles along its curving trajectory. Approximately 7 minutes and 20 seconds remain in the 10-minute built-in hold. We remain at T-minus 10 minutes and holding. This is Voyager Launch Control. This is Voyager Launch Control. Approximately 5 minutes and 20 seconds remain in that built-in hold. The Martin Marietta test conductor will shortly be pulling the test conductors to see if the various stages are ready for launch. We'll plug that action into the loudspeaking system.
Personnel switch to channel 1 for status and communications check.
Roger. All personnel switch to channel 1 for a status and communication check.
This is VTC for a status and communications check. CTC first.
Roger. Centaur status check. Propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
Flight control.
Go.
Vehicle power.
Go.
RF systems.
Go.
Telemetry.
Go.
Launch control.
Go.
Range safety command.
Go.
LOX control.
Go.
Hydrogen control.
Go.
Environmental control system.
Go.
Instrumentation.
Go.
CTC to VTC Centaur is go.
Roger. Titan status report. Electrical. Go. Instrumentation.
Instrumentation is go.
Flight controls.
Go.
Flight safety.
Flight safety go.
Facilities propulsion.
Go.
Sequencer.
Go.
ALRC.
ALRC is go.
LCC.
Go.
Quality.
Quality go.
Engineering.
Engineering is go.
VTC Titan is go.
Roger. SRM for a status check. Engineering. Engineering is go. Instrumentation.
Instrumentation go.
VTC SRM is go. Roger. Spacecraft.
Spacecraft is go.
Roger. Range. Range is go. Pad safety.
PSO is go.
Roger. Launch director.
Roger. Resume the count at the end of the built-in hold.
Roger. Sequencer is VTC.
Go ahead.
We'll pick up the count at 12:46 GMT.
Roger.
On my mark.
Standing by.
This is Voyager Launch Control. Approximately 3 minutes remain in that built-in hold. This is Voyager Launch Control. This is Voyager Launch Control. The count now stands at T-minus 10 minutes holding. 6 minutes, 6 seconds remain in that built-in hold.
T-minus 10 minutes and counting.
We have just emerged from that final 10-minute built-in hold. This is the 7th and final mission now planned for the very successful Titan Centaur rocket. It was a launch vehicle for the twin Helios missions carrying spacecraft in towards the Sun. It launched its twin Viking missions to Mars in 1975, and it was a launch vehicle for Voyager 2 on August 20th. Titan Centaur stands 160 feet tall, and the rocket stages measure 10 feet in diameter. At liftoff, those twin solid rocket motors will produce 2.4 million pounds of thrust. The solid rocket motors will be jettisoned at approximately 2 minutes after liftoff at an altitude of 36 miles. Those expended solid motor casings will impact in the Atlantic Ocean approximately 170 miles east of Cape Canaveral 10 minutes after launch. The Titan and Centaur stages will be burned sequentially to place Centaur and Voyager in a 105-mile-high parking orbit 9 minutes and 38 seconds after liftoff. After a 43-minute coast period, the Centaur stage will be reignited to the west of Australia for a 5.5-minute burn, which will bring spacecraft velocity up to 28,500 miles per hour. After Centaur separation, Voyager's propulsion module will be ignited and burn for 43 seconds to raise its velocity to 32,481 miles per hour. Propulsion module, mission module separation will occur 74 minutes after liftoff. The count now stands at T-minus 8 minutes, 22 seconds and counting. This is Voyager Launch Control. This is Voyager Launch Control. The count now stands at T-minus 5 minutes, 50 seconds and counting. All continues to go well, heading for liftoff of Voyager 1 from Complex 41 at 8:56 a.m. For the information of those viewing the launch from the KSC Cape Canaveral Air Force Station area, Complex 41 is located at a distance of 20,000 feet from Press Site 3 to the southeast of the Vertical Integration Building. The distance from the launch pad to the NASA Causeway viewing area is approximately 27,000 feet. It is about 12 miles to Jetty Park at Port Canaveral and to Titusville, and about 15 miles to Cocoa on the mainland. The count has now reached T-minus 5 minutes, 10 seconds and counting. All continues to go well at this time. All continue to look well at this time.
Centaur propulsion ready.
Roger. Environmental control ready.
Roger.
T-minus 2 minutes, 30 seconds. All Titan recorders to on.
Recorders running.
T-minus 2:15. We are rating a range clearance to launch.
T-minus 2 minutes.
Range Safety Command to arm.
Roger. RC armed.
Roger. Centaur power to internal.
Roger.
PSO item 2 under 2.
Ignition enabled.
Centaur power on internal.
Roger.
$90 seconds.
Secure and LH2 tank.
Roger.
Hydrogen systems ready.
Roger.
75 seconds. Schematic tray.
Roger.
Securing center lock stopping.
Roger.
T-minus 1
Lock
minute.
system ready. 60
Roger.
seconds.
Arm permit switch to auto.
Auto.
Launch directors go. Centaur to launch permit.
We have a verification of a green or no holds light on the launch control console, clearing the way to go to automatic sequence at 32 seconds.
Launch sequence started.
The count is now on automatic sequence, and the count will proceed down to 0 in ignition as Centaur's digital control unit and the Titan control monitor group perform the remaining critical functions. T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
MDS.
We have ignition. We have a liftoff.
Roll program is in on time. Vehicle response is normal.
TVC bus voltage look good. Tank pressures look good.
Okay, MDS.
Hitch program was in on time. Vehicle response was normal also. Very smooth flight. Very, very small attitude disturbances.
Report a very smooth flight so far, no problems at all.
TV tank pressures look
T
very
plus
good.
40 seconds.
Solid motor chamber pressures look very good. Very smooth flight.
Very smooth flight so far, no problems at all.
Vibration levels appear to be very low.
T plus 1 minute.
ECU appears to be performing normally. Vehicle response remains very light, very little steering.
Everything looking very good so far, no problem at all.
TVC tank pressures are holding up good. Go ahead.
The hydrogen vent valve has been
Away.
open on time.
Things still going very smooth, no problems at all.
VIB safety, copy.
Forward bearing reactor has been jettisoned, or has been activated, separated.
Forward bearing release has been activated, Mark 1, everything going good.
We had shutdown of the solid rocket motors.
Solid shut
Start
off.
system securing Centaur.
Safety 1, this is
We've
VIB
ignited
safety.
the Titan Stage 1.
There's separation.
Chamber pressures look very good.
Locks and hydrogen tanks have been vented.
Separation is been
We have
confirmed.
jettisoned the boosters from the Titan.
Hydrogen tank is vented.
T plus 2 minutes 20 seconds. Those expended solid
Things
motor
still
casings
look good.
will-
We have very little to report. Very smooth.
will impact downrange about 170 miles east of the Cape, 10 minutes after liftoff.
ATC, we're out of data here.
Coming up on the 3-minute mark.
40 bits? Yes, we've been locked up 40 bits. Staying in lock.
Titan first stage continuing to perform very well, putting out about 470,000 pounds of thrust.
The Titan stage still burning well.
That Titan first stage still has approximately 1 minute left to burn.
Everything's still looking very smooth.
Forward seal has been released on time.
Forward seal's been released on time. Everything going great.
That's your SE in lock. It's going in and out.
Roger.
Yes, thanks.
All the DCU functions appear to be normal at this time. The Titan stage 1 continues to burn well.
Titan stage 1 still burning very well. No problems at all. Crisp looks right on the money.
T plus 4 minutes. About 15 seconds left to burn.
We have Titan stage 1 shutdown, Titan stage 2 ignition, and separation of the two Titan stages, all on time and normal.
2 from 1. Everything going good.
Titan stage 2 seems to be burning well. Shroud has been jettisoned.
Jettisoned. Mark 7.
Shroud jettison appeared to be normal.
Those events took place some 270 miles downrange at an altitude of about 75 miles.
No problem at all.
The S2 engine, S2A engine is on. It is now off and the yaw engine on. This is per program.
T plus 5 minutes. Some 2 minutes and 40 seconds remaining in the burn.
decayed as
Titan second stage.
Titan stage 2 still burning normally.
Everything's still burning normally. Looking very good on the crisp.
Yes, just had a glitch in the data there.
The Y1 engine is off and Y2 is on.
We're locked back up.
Roger. And the Y2 is off, all on time.
Events occurring right on time. No problem at all. Crisp still looks very good, right on the money.
Centaur propulsion parameters look good. Venting appears to be normal. DCU functions appear normal.
T plus 6 minutes.
Stage 2 continues to burn well.
This thing's still looking very well.
PSO to VTC.
Go ahead.
Everything's still looking real good. No problems at all.
PSO to VTC.
Go ahead.
Preliminary look, looks like we got a clean pad. The locks and the hydrogen farm looks good. There's no sign of a fire. There's so far going through this south gate. The only report was that we still have water on.
Roger, it'll stay on for another 4 minutes here.
Understand.
And that was a report on the pad condition at Complex 41 after liftoff. We're coming up on
everything looking very well so
7
far.
minutes.
No problems at all.
On my mark. Mark, 7 minutes.
Continues to burn normally.
40 some seconds remain until shutdown of that Titan second stage.
MDS had a glitch in the data. Locking back up.
Boost pumps have started.
Centaur boost pumps have started.
Vehicle is pressurized.
Out of sync.
Centaur is pressurized.
FDS out of sync.
Roger.
MDS Bit synchronizer is locked at 40 bits.
3 sync. 50S back in lock.
This is VIB safety.
Have Titan shut down.
Shut down.
We have Titan Centaur separation.
We have Titan Centaur separation.
We have pre-start on the Centaur.
Centaur's got pre-start.
Main engine start.
Main engine start.
Both engines are up and burning well.
Both engines up and burning well.
Chamber pressures look good. All pressures look good.
All pressures looking good.
First burn of the Centaur stage will last for a minute then.
DCU functions look good. It looks like the Centaur is off and running
The events
fine.
took place some 960 miles down in range at an altitude of about 105 miles.
DCU continues to look good.
Everything's still looking good. No problems at all so far.
The DCU is the Centaur's guidance unit. All events in this flight have occurred
Now
on
operating
schedule.
on Antigua data here. The data appears to be pretty good. The vehicle is still doing just fine.
About 35 seconds remaining in that first burn of the Centaur stage. T plus 9 minutes, 30 seconds. Just a few seconds away from Centaur shutdown.
The pitch and yaw engines have all been turned on per program.
Pitch and yaw engines are on for program on a Centaur. Everything looking good.
The engines are all off on time.
All engines off on time. Looking good.
We have MECO, main engine cut off.
Centaur, main engine cutoff has been confirmed.
MECO appeared to be normal.
Centaur and Voyager are now on a 105-mile-high parking orbit, heading down over the South Atlantic on a trajectory which will carry them south of the tip of Africa,
Data now wall until we get to
and again to the north and the west of Australia.
When's that due?
All events in this flight have gone on schedule to this point.
The vehicle performance, based upon the telemetry data, looks very good at this time. We appear to be in a normal coast.
Centaur looks like a normal coast. Everything looking good.
TS3 sync.
Those reports you're hearing are
this
coming
is,
from
launch
Skip
spec on
Mackey
channel
of PSC's Expendable Vehicles Directorate.
PTC. Are you on one?
Centaur
Roger.
and
There you go.
Voyager 1 are now in a
The press conference for
parking
this
orbit.
one,
It's VIB safety. Go ahead.
press conference is
last
going
for
to
about
be 2 hours
14
after
minutes.
launch, which would be 11.
T plus
If everybody
10
can make
minutes
it, I
and
thought we'd
55
try to
seconds
have
is Voyager
the
launch control.
debriefing for the test team at 10:30 over in the mission.
This is Voyager launch control at T plus 20 minutes and 20 some seconds. Centaur and Voyager 1 remain in that 105-mile-high parking orbit. Approximately 32 minutes remains before we have the restart of the Centaur stage. All continues to go well at this time. This is Voyager launch control at T plus 20 minutes, 49 seconds. This is Voyager launch control at T plus 36 minutes, 30 seconds. Centaur and Voyager remain in that coast period in a parking orbit. Some 16 minutes and 15 seconds remain before Centaur is to be reignited for that second burn. That second burn is to be in excess of 5.5 minutes. And that should be coming up in approximately 16 minutes from now at T plus 37 minutes. This is Voyager launch control. Please. This is Voyager launch control at T plus 43 minutes and 46 seconds. Centaur and Voyager are now in that coast period off the west coast of Australia. Just 9 minutes remains before the restart of the Centaur upper stage. That burn will be tracked by Araya aircraft. The duration of this burn will be in excess of 5.5 minutes, and that burn is now at just slightly in excess of 8.5 minutes away at T plus 44 minutes and 30 seconds. This is Voyager launch control. This is Voyager launch control with T plus 51 minutes and 50 seconds. We're just about 1 minute away from the restart of that Centaur stage. Press up the command channels coming back so you can hear what they're saying as we near that burn.
Synchronizer is locked up here now. It's been flicking around, now it's locked up.
They're out at the moment.
I was trying to punch up Skip Mackey as he picked up.
Now they're back in. Circ pumps are on, I believe, based upon a little bit of data here.
We went right back.
We started the engines. Both Centaur engines are up and burning well, and the feedback pots indicate that we are in good control.
Back in lock.
That was Skip Mackey confirming Centaur reignition. This burn should be in excess of 5.5 minutes. That burn was started to the northwest of Australia, being tracked by a Raya aircraft.
A little piece of data here indicates that the guidance has been enabled and is steering the Centaur at this time, and the vehicle looks very good. Continue to get good data from the Orion showing a normal burn of the Centaur.
90. Very good. Engineering 72.
Just
7-8. Roger, very good.
It's under 7 minutes now to Voyager separation.
TC, CCS. Go ahead. Our first bit of data says we have an event count of 14, which would be the event count before the 3 alpha. Roger. We should be.
We had LOS on the spacecraft.
Still good data from the Orion 1, and still a normally burning vehicle.
Still have high BIC 2. Roger.
That first bit of data looks like a CCS hour pulse.
All right, there should be a CCS hour pulse 3 minutes ago.
Riot 2's got AOS. We'll stand by for decom.
Still showing good Orion 1 data and a normally burning vehicle.
Launch vehicle still looking good.
Skip, do you get an overlap with Orion 2 so that we know that they'll be up while we still look at Orion 1?
Yeah, there'll be we don't see it here. The Tel4 will make the switch for us, but there's plenty of time.
Okay.
We're already past the nominal acquisition time for Orion 2, and we still have very clean Orion 3 data. Orion 1 data, sorry. We have burned 3 minutes on the Centaur and can continue to burn well. We have had LOS, Orion 1.
Orion 1 has lost signal. There's 5 minutes remaining.
Real-time strip charts have not been switched. There we have Orion 2 data now.
The second Orion
Data's coming back.
Space vehicle.
Everything we can see down here, Ops, looks good.
All right, thank you.
MD has headed which?
We still have not gotten good lock on the Uriah 2 data. It looks like they're having a decom problem at the station.
MD has headed which?
Still no Uriah 2 data to look at. Understand they have the signal, but we're not getting it here.
Will Uriah 2 call out the mark event even if we don't have the data?
They're supposed to, yep.
Thank you.
We're having Telefora switch among all the available sources looking for something that's coming in good, but at this time we don't see any data. The engine will have been burning.
All the attitude control stuff is good. The only thing we haven't got so far is gyro status, which we were interested in.
Vanguard AOS isn't until 3600. We're not going to make it. Plus they're early. Hey, we got something. We got some data, and it's still burning. It's up and burning, and this is Uriah 2. It has the characteristics of...
Okay, launch vehicle still burning. We got data back for the launch vehicle now. Still looking good.
We have main engine cut off. MECO was sharp and clear.
We have main engine cut off
has
for 2.
been confirmed. Control of the spacecraft will now be passed to the Jet Propulsion Laboratory in Pasadena.
It sure looked like a velocity cutoff to everybody who looked at it.
Confirmation of the shutdown of that Centaur final stage has been confirmed. Control of the spacecraft now passes to the Jet Propulsion Laboratory in Pasadena.
Good morning. This is the Voyager Mission Control at the Jet Propulsion Laboratory in Pasadena. I'm Alan Wood, and we have the good fortune this morning to have with us again Ron Draper, who is a mission analyst for the Voyager and Voyager Engineering Design Chief. We're coming up now on the spacecraft should be aligning itself, the Centaur should be aligning itself for the separation of the spacecraft from the Centaur. The purpose of the alignment is what, Ron?
Simply to get us started in the right direction. And when we then get the separation event, the springs push us off, and we then are on our own, and we then stabilize again on that attitude that the Centaur set us up on. Then we take over, and shortly thereafter we will ignite the 100-pound engines, 5-pound engines for control, then ignite the solid rocket, which really injects us on our own orbit out to Jupiter.
The next event will be the turning on of the command and computer subsystem clock, which is the master clock on the spacecraft that times all of the events for the whole mission.
As a matter of fact, that clock will actually, once it's started by the Centaur, will cause us to fire the separation event itself, and we then separate on our own right from the vehicle.
Following the turn on of the clock, we'll have spacecraft separation, probably in about a minute and a half.
That's right. Now, shown on the hard copy at this time is a photograph showing the spacecraft in its launch configuration. And the science boom and the RTG booms are both down next to the side of the spacecraft to give it strength to protect place at this location between an adapter that we build to go to the Centaur and the spacecraft itself. We now have spacecraft separation. Now, after the spacecraft separation, we then fire the solid rocket, and shown on the hard copy here again is what the propulsion system looks like. We have 100-pound engines that give us pitch and yaw control, 5-pound engines which give us roll control, and then we fire the solid rocket motor which gives us the injection itself. All of this fuel for the liquid system, the 100-pound to 5-pound engine, comes out of a central tank that is located up interior inside the mission module. And when we get ready to jettison the propulsion module, we separate at the location indicated here where this 4x4 strut arrangement combines with the propulsion module structure.
Okay, we have confirmation that the propulsion module has started, and we also have the burnout confirmation. Also during this time, the shutters of the star trackers and the sun sensors have been blown off. So the propulsion module, which has 2,290 pounds of solid propellant in it, has burned completely in a very short time, and we'll soon know how well it went. The altitude of the spacecraft is now 736 miles. Its velocity is now 32,481 miles per hour. It is located in the western Pacific near Guam. It is now on a transfer orbit to the planet Jupiter. The next event that will come along very shortly here, the spacecraft should now be pitching over in preparation for the propulsion module separation from the spacecraft, from the mission module, I should say. Now, why is this
Well, we pitch the spacecraft down so that we get good communications with the Earth. And so when the low-gain antenna is located closer to the Earth, we can hear it better. And that way we can then see the separation of the deployment of the RTG boom and the science boom, and then the separation or jettison of the propulsion module itself. At this time, we are coasting with the, as the model indicates, with the RTG boom and the science boom both latched down to the side. We've finished using the solid rocket motor, and we are using the 5-pound rocket motors at this time for control. Now, we pitch down at 2.88 degrees per second, about 114 degrees to point the low-gain antenna, which is mounted on the upper side of the high-gain antenna and operates at S-band. We can both command and receive over this. But at the present time, we only have downlink transmitting capability.
Okay, we have confirmation now that the science boom has deployed and the RTG boom has deployed. So now the spacecraft has begun its rather elaborate procedure of unfolding itself in space.
Of course, as you remember, Alan, the last time we did this, we had the RTG fully deployed and latched in position, but the science boom did not get an in-lock indication, and later we determined that it's very nearly in the right location, but the microswitch never did give us an in-lock indication. It may actually be fully locked in position. On the photograph now, on the hard copy, we actually see all of the booms deployed. At this time, the PRA and PWS science instruments antennas and the magnetometer boom have not yet deployed. So presently we have the RTG boom starting deployment and the science boom starting deployment, and we will get an in-lock indication for each of those shortly.
The next event that should come along will be the slew of the high rate slew of the scan platform, and that will be to do what, Ron?
That's to protect the science instruments. The way we had to latch the science scan platform was in such a way as that if we deployed it and then acquired the sun, the sensitive instruments would be pointed at the sun. So we rotate the scan platform around so that it looks at a science calibration target, gives it a place to hide as we do the sun acquire maneuver. This way there is virtually no likelihood that a science instrument would see the sun, even if we had to go through 4-pi steradian, look for the sun as we started to last time.
The scan platform, of course, is the portion of the science boom which contains the optical instruments, which have to be pointed at the planets Jupiter and Saturn and the satellites as they go by, and that is why it's mounted on the end of the boom and so it can be moved down.
That's correct, Alan.
We should be now at a point where that process begins.
While we're waiting for those to take place, I'll show a photograph of what those science instruments look like out on the end of the science boom. And they are very large science instruments. We have something like 125 kilograms of science on board the spacecraft, of which most of it is located out here in the science boom. We have an IRIS, which stands for infrared radiometry and spectrometry, a photopolarimetry instrument, the narrow-angle TV camera or imaging, wide-angle imaging, and we have an ultraviolet spectrometer over here next to the IRIS.
For the non-metric people, that's about 254 pounds of instruments out there.
That's right, Alan. We'll eventually get all of the system of the world converted here.
The next event after the slew of the platform will be the propulsion module separation. And we are now launch plus 1 hour, 9 minutes, and 13 seconds, and the altitude of the spacecraft is now 2,732 miles, traveling at a speed of 29,953 miles per hour. It is going away from the Earth very rapidly. In fact, it passes the moon. It will pass the moon approximately 10 hours, I believe. Is that right, Ron?
It's about 8 hours. We're actually really moving.
Faster than that.
That's right.
It's a much faster trajectory than the Voyager 2, which was launched on August 20th.
Now, at this time, we started off with the spacecraft total weight, including the adapter, 4,589 pounds, and we left with the Centaur an adapter that weighed 104 pounds. That gave us a total of 4,485 pounds, which we separated from the Centaur. And then we burned the solid rocket motor, and we're left with 350 pounds that were in the propulsion module when we jettisoned it. At the time of jettison, then, we are left with 1,820 pounds of mass, which we are injecting on orbit all the way to Jupiter.
Very good. I think now we'll check out for a few minutes. This is Voyager Mission Control. Out. Voyager Mission Control. We just have had confirmation of the separation of the propulsion module from the mission module. So far, all of the events have come off on time, as planned, no hitches. Apparently, the fixes have been made properly to Voyager 1. We haven't had a problem at all yet with Voyager 1 as compared with Voyager 2, Ron?
That's right, and the fixes were all positive sort of things. We've added additional springs to the actuator, which deploys both the science boom and the RTG boom. We also added additional springs at the on the booms of each of those to latch the strut in location, and we removed the gyro check that was taking place early in the launch phase and put it down in the coast phase. As a result of that, we did not switch gyros either of the two times we did earlier in the launch of Voyager 2. Now, we are in all-axis inertial control at the present time of the spacecraft, and we have not switched plumbing like we did last time, as a direct result of removing a few events which were made to add additional safety but caused additional problems for us the last time. And so it's working right on a textbook kind of a launch and sequence for a Sun Acquire.
The next event coming up will be the acquisition of the spacecraft by Station 12 at Goldstone. That is, it's probably seeing the spacecraft already, but the process of locking up on the signal takes some time. This should come along in a few minutes when the spacecraft is approximately very close to 6,000 miles away from the Earth now, at least in altitude, and traveling at 27,873 miles per hour. As I said a moment ago, the events have all been absolutely perfect this morning on the spacecraft, and from all we can tell from Dick Young's commentary at the Cape, that all of the launch events of the Titan Centaur went off as planned. So we'll sign off here for a moment, for a few minutes, and we'll wait for the next events, which will be the turning on of some of the scientific instruments on the science boom of the Voyager 1 spacecraft. This is Voyager Mission Control, out. This is Voyager Mission Control. We now have confirmation that the station at the Goldstone, Station 12, is now in two-way lock with the spacecraft. We also have confirmation that both of the latch springs, the latch microswitches, have sent signals to the ground that they are in place. The booms, both booms, are fully deployed with the struts locked in place, and that's another milestone for Voyager 1 performance over Voyager 2. The next event will be the turning on of some of the science instruments. First off will be the plasma wave instrument, and that's located on the same side of the spacecraft as the RTG boom. Is that correct? Am I correct on that?
That's right. The plasma wave instrument is located above the electronics module on the bus, and is a very simple small box which contains a receiver indicated in the photograph on the hard copy. It's an instrument that weighs a little over 3 pounds, takes a little over 1.1 watts to operate in cruise and 1.6 watts to operate in encounter. And it's really a receiver that looks for electric fields of plasma waves over a frequency range from 10 hertz to 56.2 kHz.
That's mostly plasma from the sun.
That's right.
Right.
And it has 16 different channels that it steps and frequencies to analyze, and then we have an additional waveform analyzer that we put on at encounter times and give it very high data rates at those times.
Yeah. The next instrument to come on following the plasma wave will be the low-energy charged particle instrument, which is also measuring particles coming from the sun. And do they follow the magnetic field lines as the plasma wave does, or is it a different kind of radiation from the sun? Is it a straight line, or is it float by like a wind, or what?
I believe, but I'm not a scientist, that these particles are on the magnetic lines coming from the sun. And this instrument has a little turret that rotates, and is indicated here on the hard copy camera. The upper part are the detectors, and they move with optics which look for the electrons and for ions, and then in the top is another set of apertures which look for particles coming perpendicular to those. Now this instrument weighs about 14.5 pounds and takes 5 watts to operate it, and it's working in electrons with energy ranges from 6,000 volts to 10 megavolts, protons 10 kvolts to 150 megavolts per nucleon, and then it looks for heavy nuclei all the way up to iron.
So that's a lot of science from the sun. The next event will be the magnetometers on, and we have confirmation that the magnetometers are on. And I believe we did get confirmation that the plasma instrument and the low-energy charged particle instrument are on.
That's correct, Alan.
The next event following the magnetometer turn-on, we will do some ranging, the spacecraft two-way ranging, which will begin the accurate measurement of the location of the spacecraft and start the process of plotting its course accurately to Jupiter, performing maneuvers and so forth along the way. And then following that will be the release of the magnetometer boom. And I think Ron maybe could show us a picture of that. This is a very unique piece of equipment on the Voyager. It really shouldn't be called a boom. I think of a boom as being a great piece of wood that has big blocks and tackles on it and things like that they use on ships to unload. This looks to me like more of a trellis that carries vines on it or something. Actually, I understand the boom itself weighs less than the power cable that goes out to the magnetometers.
That's right, Alan. This is quite a small structure in itself, and indicated in the photograph is a deployment canister which has a lanyard which keeps the boom from going out too fast. The boom is 13 meters long, or 43 feet, and has 3 longerons, and then every 5.6 inches are cross bays which hold it together to keep it structurally sound, and then it has lanyards which actually hold it in position. This is all coiled up in a canister which protects it during the launch phase, and then it deploys from the end as it moves out. And there is a magnetometer 0.53, the distance of the boom out on it, which we call the inboard low-field magnetometer. And then on the very top of it, or very end of it, is another one, which is the outboard low-field magnetometer. The total structure of the boom itself weighs 5 pounds, so it is very light for this 13 meters in length.
What keeps it from flopping around? I would think that this thing would be would move quite a bit during maneuvers and that sort of thing when the spacecraft is rolling and pitching during maneuvers.
Well, the structure itself is fairly strong, even though it doesn't look nearly that strong, and it does move around a little bit, but the thrusters on this spacecraft are much lighter in weight. Each one of the thrusters are 0.2 of a pound when we do attitude control, and then when we do the trajectory correction maneuvers, we actually fire 4 of those at a time in order to get us control. And as we begin to move off, when we turn off 2 of them, and to get our control. And so we don't have large forces moving us around on this spacecraft like the conventional mariners with 50-pound engines or 100-pound engines.
Yeah. Okay, very good. We have confirmation that the magnetometer boom has been released and is now winding its way out. It takes it how long to get out? Does it go out very quickly, or is it just a matter of a few minutes or a minute or two?
It takes a few minutes to go out, and it actually rotates 22 turns as it goes out all the way. And the magnetometer is actually sampling that data, and the PI is counting those untwist turns to verify that it gets all the way out. And then there is a microswitch closure at the end of its deployment.
Another microswitch?
That's right, to verify that it really got all the way out.
Okay. We'll wait for that. Right now it's launch plus 1 hour and 31 minutes. The spacecraft is now 12,099 miles above the Earth, traveling at 26,105 miles per hour. We'll sign off now for a few minutes because the next event will be the roll turn for the sun search, and hopefully when that comes up we'll have confirmation of that magic microswitch on the on boom for the magnetometers. This is Mission Control, out. This is Voyager Mission Control. We have confirmation that the magnetometer boom is extended. we are now coming up on the start of the roll turn for the sun search. The roll will last for about 3 minutes, and it will be followed by a yaw turn of approximately 6 minutes. This is to align the sun sensors in the proper direction to view the sun, which will put the spacecraft in a stable position, at least in one axis. And then there is a slight offset built into this so that the sun sensor is not looking directly at the sun. It can't do that, as I understand it. Is that correct, Ron?
So what we actually have is we will start this minus 14.5 degrees, which will bring us around, and then we'll yaw minus 51 degrees, and that'll point us directly at the sun. But as soon as we have sun acquire, and then we start doing the Canopus acquire, at the conclusion of the Canopus acquire events, we will then bias the spacecraft off 11 degrees in pitch, 11 degrees in yaw, which will point the low-gain antenna closer to Earth, improving our communications, and also having the sun sensor look at a part of the sun look at a part of the sun sensor, which we only use during the early part of the mission, which with this intense sun that we have now will only do any damage that it does at that point, as opposed to part we need out at Jupiter or Saturn.
Now, we will have good communications, however. Even though we're pointed towards the sun, the low-gain antenna will be able to transmit data from the spacecraft.
That's right. Now, we have indication from the magnetometer people that the boom was deployed as we expected with the right number of turns and is fully deployed.
Very good. So, Voyager 1 has been performing almost flawlessly this morning, except we had one minor glitch. There was a plumbing swap a while back, which means that the one set of thrusters was switched to the second set of redundant thrusters. What does this mean to us?
Well, because we've only had one, that's not really a serious problem. We either got an indication of too many thruster firings during the period of time as we were stabilizing, or we got a slightly larger turn than we would have expected. And either one of those two will cause us to switch from one set of plumbing to the other set. And if we were to get a similar event again, the next time we would switch the electronics, or HIBIC as we call it, and rather than the plumbing. And as we had on Voyager 2 when we launched it, we went through that stage several times and still successfully were able to get stabilized on the sun.
Yeah, we all remember that very well, I guess. So, we should now be at the end of the roll turn for the sun search part of this. The next event will be the yaw turn, and then hopefully the acquisition of the sun. So we're going to sign off now for a few minutes. This is Voyager Mission Control, out. This is Voyager Mission Control. We have confirmation that the yaw turn has started in this sequence to locate the sun and locate the sun sensor facing the sun. Ron has a picture here of the sun sensor for those people that are at JPL here who can see the picture and can describe a little bit about the sun sensor to us now. Ron, go ahead.
This is a photograph showing the interior and the electronics of the sun sensor. The two detectors are totally redundant for both the pitch and yaw, each of these. They have a hood that mounts over the top of them, and then in its finished configuration, looks like this closed box with small openings which let the sunlight into the detector. On the sides of the sun sensor are RTGs, 6 of them, RHUs, which stand for radioisotope heater units, 3 on each side, each producing 1 watt by radioisotope thermal decay of heat. And the sun sensors are mounted on the high-gain antenna, and as indicated in this photograph, and actually look up through the high-gain antenna at the sun on the far side. In order to maintain the thermal control of these sun sensors, there are 3 louvers which open up to let additional heat out, and then we have 2 heaters which are turned on when we get quite some distance from the Earth as a way to keep them warm.
We will finish this minus 51.3 degree yaw turn shortly and actually have the spacecraft using these sun sensors pointed directly at the sun.
So the yaw turn should end shortly. We'll go off the air now and come back as soon as we get confirmation of that event. This is Voyager Mission Control out. This is Voyager Mission Control. We have confirmation that the yaw turn has ended. The spacecraft is now 18,442 miles, 242 miles above the surface, traveling at 25,278 miles per hour. The actual sun acquisition will take place in roughly about 15 minutes from now. So
Actually, we have the sun in the field of view of both the wide-angle portion of the sun sensor and the narrow-angle field of view of the sun sensor. The guidance and control analyst has just reported.
Very good.
So we are actually in the sun-acquired position, but we're in all-axis inertial control at the present time.
So that means that the enabling of the sun sensor itself, or of that part of the attitude control system, comes later.
That's right, but the sun is actually there, ready to be acquired.
Well, that's good news. This is Voyager Mission Control, out. This is Voyager Mission Control. As we announced earlier, the spacecraft completed its yaw turn in the sun acquisition sequence. The sun acquisition itself will take place in roughly 15 minutes from now. All of the events so far from launch through this sun acquisition sequence have gone off as planned, on schedule, and Voyager 1 has performed almost flawlessly. We can say now for sure that the fixes and the changes that were made following the Voyager 2 experiences have worked, and I think everyone is quite pleased. In a few minutes, we will have a press briefing down at Kennedy Space Center for a wrap-up on the launch events down there. In the meantime, while that is going on, we will have some other instruments on the Voyager 1 turned on. The planetary radio astronomy instrument will go on, and its antennas, which are about 33 feet long, or 10 meters, will be deployed.